Hey guys, sorry about that. I had to get my screen adjusted. Today we are going to look at step 2 of the lesson on absolute value equations. In my last video, we kind of went over the basics of absolute value. We started to learn how you can do an absolute value equation through the following steps. We talked about number 1, make sure the absolute value part is isolated on the one side of the equal sign. There's no adding, there's no subtracting, there's no multiplying or any of that other stuff outside of the absolute value bars. So step 1, we always had to undo everything that's outside the absolute value bars. Step 2, then we could, once we had it isolated, check and figure out how many answers we would have. Step 3, we would split it into 2 equations, positive and negative. And then finally, step 4, we would solve it. So today we're going to look, this is actually in your journal. I've got it zoomed in so far, you can't really tell what page it's on, but it is in your journal on page 21. You can see right there. I just got it zoomed in super close to give me plenty of room. What do you do when you have absolute value symbols on both sides of the equal sign? And that is something we never got to in my class. And so we're going to save that for tomorrow on Thursday, which Thursday might be the actual day that you're watching this. So this is going to be Thursday's lesson for my class and probably Miss Bo's classes as well. So whenever you have absolute value bars on both sides of the equal sign, you can basically do step 2 and 3. You don't have to worry about isolating and checking to see how many answers there are right now. You can go straight to split it into 2 equations. And let me show you what that means. So if they give you absolute value bars on both sides of the equal sign, what you'll do is basically the same thing we did on the others. We will do 20x. Oh man, it's not letting me write. That's going to be bad. If this doesn't let me write on here, I'm going to be sad. Oh boy. Oh boy. Okay, I see how we're going to be. All right, well, we can do it this way. Not a problem. Let me just grab my book here and see what it was, because that's not going to let me write on it. I thought I could write on there. Sometimes it lets me and sometimes it doesn't. This time it didn't want me to write on there, and that's okay. So look like this. Okay. You have absolute values on both sides. It's number 6. Whenever you see this, your job is going to still be split it into 2. One time, you'll do 20x. The other time, also 20x, right? Those don't change. But when you do the right-hand side, remember how we did the other ones. One time you would do this part just like normal. So we're going to just copy it down just like the way it looks. See how this and this are the same thing? It's just like the bars are gone. So over here, it looks completely normal, except I just removed all the bars. On this one, instead of doing 4x plus 16, I'm going to do -1 or negative. You're basically going to do the opposite of 4x plus 16. So I always like to put it in kind of a distributive property question with that -1. If you are just really, really cool and you think you can be an advanced person, honestly, what that's going to do is it's going to switch all of the signs. Switch every single sign, not just the first one, but every single positive is going to go to negative, and every single negative is going to go to positive. It'll work like that if you would rather do it that way. So do you see how we did that? We just split it once, keep everything the same, right? 20x equals 4x plus 16. On the other side, it's still 20x, but over here, when you go to the right-hand side, now all of a sudden you take this and you multiply everything by -1. That's basically all there is to these. So on the left-hand side, everything looks normal. You just took away the absolute value bars. Everything is the way that it looked before. On the right-hand side, in blue, the 20x is still the same from up there, but then the right-hand side of the equal sign is multiplied by -1. And basically, sorry about the bell. Basically, that's the only new concept. Once you get to this part, everything you do from here is exactly the same that we did yesterday, right? I'm still going to solve this. My step is going to be, I don't want to do minus 16 because there's not a plain old number over here to multiply or subtract it with. So I want to do minus 4x. I need to get rid of the variable on the right-hand side. I've talked about in my class a lot that I don't like variables on the right-hand side. They just look funny over there. They're really not supposed to be there, at least in my opinion. 20 minus 4 is 16. And here, 16 divided by 16 is 1. Whoops, I probably shouldn't have circled that yet, but I'll do that in a minute. On the other side, same idea. I've got to distribute first though, right? I'm going to do negative 1 times 4x. I'm going to do negative 1 times 16. Do you see how that just changed the signs, right? Now I have negative 4x and negative 16. Back in the original problem, we had positive 4x and positive 16. And so this is like the negative version of this, right? Remember how like negative 6 and positive 6 both have the same absolute value? Negative 3 and negative 3 and positive 3 have the same absolute value. They're both 3 places away from 0. Same kind of thing here. I'm still going to do plus 4x. I guess over there I did minus, and this time I'm doing plus, and I get 24x. Holy cow, this one is gross. Negative 16. And then you got to divide, and this is definitely a fraction. Can I reduce that? Yes, they both go into 8. If I reduce that, that would equal negative 2/3. Right? I believe that is correct. So one thing you didn't check. Oh boy, there's the bell again. Sorry about that. Lunch is over. So one thing about these, I forgot to introduce at the beginning. You're going to get 2 answers. And we're used to just being, I mean, I don't know how you guys are. Sometimes I get to the end and I'm so happy that I'm done that I just circle my answers and I don't even check them. I'm like, oh yeah, I'm done. Finally. Thank you. Whew. I finally got to the end. I think I at least did it right. What you want to do today and all of the times is when they put a variable on both sides of the equal sign, like we see how we have x's on both sides of the problem, you want to double check and make sure what you don't have this, something you never heard before. It's called an look at that fancy word, right? Extraneous solution. What in the world is that, right? The word extra is basically a shortened version of extraneous. So an extraneous solution is a solution that you get that necessarily is not the right answer. And so, especially when you're doing absolute values, like we know absolute values can't be negative, right? So what I need to do really before I lock in my answer as the final answer, I need to go back and test it out. And I know this is super annoying because nobody wants to do it. Most of you, when you're done with a question, you just want to be done with it. You don't want to have to go back and check it, but I'm sorry. On these, sometimes it's important to do that. Right? So I'm going to go back to the original problem. I'm going to take my answer of 1 and put it right here and put it right here and see if I get a true statement. You know what I mean? So let me go ahead and erase all these arrows so it's not in my way. Oh, geez, now I erased my problem. I can fix it. So I'm going to go back to the original problem. I'm going to see if I get a true statement. So if I put 1 right here, this is 20 times 1. The absolute value of 20 times 1 is obviously 20. So then the absolute value of 20 is 20. So that's true. I need to get 20 on this side. If I don't get 20 on this side, I'm going to be in trouble. 4 times 1, that's 4. 4 plus 16 is 20. The absolute value of 20 is 20. So this answer is good. That one is going to work. Now, the other one that I don't like because it's a fraction, I need to check that one as well. So I'm going to erase this really quickly so I have room. And now I'm going to go over to this negative 2/3. And if I put negative 2/3 in here, that is gross. Holy cow. Why would they give this to you on the very first one? Oh, sweet mercy. I need to see if this is true. That is not fun. Okay, this is going to be negative. If I put a 1 over there, that's negative 40 over 3. And then the absolute value of negative 40 over 3 is just 40 over 3, right? So my answer over here is this, and that is 13.3 with a repeating bar, right? This is really 13.3 or 13 and 1/3. The calculator could have told you that. I don't expect you to know that in your head. I know it in my head, but you don't have to. Over here, this nonsense, holy cow. This is like 4 over 1, so 4 times 2 is -8. -8 over 3 plus 16. Let me double check that. Okay, so this is like -2 and 2/3 plus 16. And that is, okay, we're doing all right. That's a 1. I about put a 2. The absolute value of 13 and 1/3 is 13 and 1/3. So this one is actually good too. That was disgusting. But you see how I had to check it? Because every once in a while you'll get one where there's a negative out here, and then that doesn't work. Although this one, it would have been impossible because they're both absolute values. But it's always important to go back and check. Okay, that was really disgusting. Let's try another one. I need to just completely get that off the screen. Holy smokes. Okay, let's look at number 2. Or this isn't number 2, it's number 7. It's the second one I'm doing, but it's actually number 7 in your journal. So we're going to have this. Absolute value of p plus 4 equaling absolute value of p minus 2. I have absolute value bars on both sides. So watch again how we do this. Okay? On the left-hand side, keep everything the same. When you go over here to do this one, look, still the same, right? Perfectly. I just copied it down. And then whenever you go to do the right-hand side, I'm getting ahead of myself. When I go to copy this down, on this version, I keep it exactly the same, right? P minus 2 is still P minus 2. On the other version, whenever you do it, you do -1 times P minus 2. Okay? See the difference? This one is just the entire thing written without the absolute value bars. This, the left-hand side is the same, but the right-hand side now has been multiplied by -1. Okay, let's actually just solve this. This one is going to be kind of icky as well, because look what's going to happen. Look at this guy. I don't like having variables on the right, so I'm going to undo that. Minus letter P. Minus letter P. Now I have an issue. Here, P minus P, it goes away. That's what I wanted. But now look what happens. P minus P again. It goes away on the left. Uh-oh. How can I solve it for P if all my P variables are gone? And what I'm left with is this. 4 equals -2, because 0 minus 2 is -2. Does 4 equal -2? No way. I mean, if you wanted to keep going, you could technically maybe even do this and do +2 and +2 and get 6 equals 0. But is that a true statement? No way, Jose, this is not true. So this side is no solution. There's no solution over here. Now, that doesn't mean the whole thing is no solution, because maybe over here we will get an answer. So let's try the right-hand side. That left-hand side was a total bust. Didn't get anything. But over here, I can do it. -1 times P, -1 times -2. I can do that. And then on the left-hand side, just copy it down, P plus 4. Now, I need to solve it. Just undo something. Undo anything, right? I don't like having variables on the right-hand side, so I'm going to undo this. +1P. I'm going to add it over here. And I mean, that one has a 1 on it as well. They just don't put it on there. For the coefficient, 1 plus 1 is 2 P's. Plus 4 is still hanging out. Equal sign just hanging out. -1 and +1 P cancel each other out and equals 0. 0 plus 2 is 0. So on one side, make sure you cancel out with inverse operations, cancel out the variable. On the other side, cancel out the constant, right, the regular number. So +4 and -4 make 0. 2 minus 4 is -2. And then you get this. 2 times something equals -2. We all know the answer to that. If I really needed to show my work, even though I'm about out of space, I could. Divide by 2, and you get -1. So I went ahead and circled it like I am confident that's the right answer. It should be, but just to double check, if I put -1 up here, let me use a different color so it'll stand out. Oh, let's use this kind of teal color. If I put -1 right here, the absolute value of -1 plus 4, well, let me think about that. -1 plus 4 is 3. The absolute value of 3 is 3. And over here, if I put -1, -1 minus 2, that is -3. The absolute value of -3 is 3. So yes, this is Confirmed, 100% answer. Okay. The times whenever it sometimes won't work is if the right-hand side doesn't have an absolute value. Like if it just had p minus 2 and it wasn't in the bars, then we would have had a bad situation. We wouldn't have had any answer to this. All right, let me check my time, 15 minutes. Okay, I'll do one final question, and then that will be it. Let's do number 8 in your journal. This is number 8. It says 4q plus 9 equals 2q minus 1. All right, here it is, guys. We're just going to split it right at the beginning. Remember when you split it, the left-hand side is the same for both of them. 4q plus 9. Over here, you can use a different color, I guess, to make it stand out. Also 4q plus 9, right? I'm not messing with that. On the original one, just keep everything the same. This is itself, right? I'm just copying it down. 2q minus 1. On the second one, whenever you copy down the right-hand side, you multiply this times negative 1. You have to do the opposite. Negative 1. That's the big idea today. 2q minus 1. Okay, let's do it. I'm just going to solve each one. I don't like variables on the right, so I'm going to undo this with minus. Notice, I did not put plus. Some people see this and think, oh, it's subtracting, so I need to do adding right here. Whoa. If I do adding right here, does it equal 0? No, I would have 4 q's. That's not going to help me. I want to get rid of the q's. That's a positive 2, so I need to do negative or subtract 2. So over here, 4q minus 2q is 2. Here we have plus 9, equal sign. 2 minus 2 is 0. 0 minus 1, negative 1. And you should not need my help for the rest of it. I'm going to go really fast so the video doesn't get too long. But you should not need my help for the rest of this. 10 divided by negative 2, I'm out of space. But you would get this. Okay, there's one answer. On the other question, same idea, right? Except now we have to distribute first. Negative 1 times 2q. Negative 1 times negative 1. And then on the left, I get this. Just copied down. And now I can go ahead and solve it. Okay? Undo the variable from the right-hand side. Gross. No one likes variables on the right-hand side. They're icky. I'm going to add 2q this time. On the other one, I did subtracting. This time I'm doing adding. 4 plus 2 is 6q's. And this is going to be a fraction. Wonderful. How do I know it's going to be a fraction? Because I'm doing 1 minus 9 in my head, right? 1 minus 9 is negative 8. And there's no way that negative 8 is going to divide with 6 and go evenly. So we get this, we get this, we get negative 8 divided by 6, which is negative 1 1/3, 4 over 3, right? Okay, I technically should go up here and double check them, but for the sake of the length of the video, I'm not going to do it. I don't want the video to get too long. Let me do just one last one. I knew I said this would be the last one, but I can see in our book that they're going to be a little bit trickier than what we have in the journal so far, because the journal doesn't have any more like this. So I'm just going to do one more, and I apologize. This is going to be like a 25-minute video. This is number 11 in some of our practice questions in the book. Like, look at this thing. What do you do if one side has an absolute value, but the other side doesn't, and the other side is a variable? Remember, we saw these questions yesterday like this, but yesterday, right? Yesterday, whenever we did this, we would have absolute value on one side, and the other side would not, but this right-hand side was always a number. It was always negative 10 or, or 31 or whatever, right? We never had one where it was a variable on both sides. So if they do this, treat it like all the others. Still split it. Split the question. Well, I didn't want that one. The left-hand side, keep it the exact same. The right-hand side, or the other one, the stuff in the bar on the left is still going to be identical. The right-hand side, though, remember what we've been doing all day. We're just going to take negative 1 times whatever it is that's out there. And in this case, it's an x. Sometimes it's a number, sometimes it's a variable, sometimes it's an entire absolute value, but we'll just solve it like this. You can put a 1 on here if you really want to help you. Oh, holy cow, how would I solve this? This is gross. Oh, geez. I would actually do this. Some of you would not do this. Some of you would go in a different order. I spent the whole video saying how I don't like a variable on the right-hand side, and now look, here I have a variable on the right-hand side. This is the only time I do it, whenever there's nothing else on the right-hand side. Negative 2 divided by negative 2 is 1. So this has one answer of 1, and on this side, you're going to do negative 1 times x, and then you're going to get this. And once again, normally I would say get rid of the variable on the right, but when it's the only thing there, I'm actually going to get rid of the variable on the left. And look at this nonsense. All negatives. Gross. 0 minus 2 is negative 2. Negative 1 minus 3x is negative 4x. And then you divide by negative 4, and you get this. Negative 2 divided by negative 4 is 1/2. So these are the ones where you need to be really careful that you don't have an extraneous answer. So check these. I circled them like I knew, but you really need to check these. Put 1 right here. If you do 3 times 1 minus 2, that would be 3 minus 2. 3 minus 2 is 1. Is the absolute value of 1 equal to 1? Yep, so that one's good. Now let's do 1/2. If I put 1/2 in here, like if I put 1/2 right there, and then I put 1/2 right here, 3 times 1/2 is 1.5. Does 1.5 minus 2? That's negative 1/2. Does that have an absolute value of 1/2? It does. So that one actually had 2 answers. So I'm seriously going to stop. That's how you'll do a question if only one side has an absolute value, right? Still split it. Still do it just like we did. And the only difference is one side is going to have just x. The other side is going to have negative 1 times whatever this is. So you still split it. You still do this side with positive. You still do this side with negative out here after the equal sign. Okay, I'm going to be done with this because 22 minutes is way too long. I'm going to stop. I will post some questions eventually for tomorrow, Thursday, whenever you watch this video. It may not be tomorrow. It might be today by the time you watch it, if you're watching it on Thursday. So this is going to go live right now, but this is not an assignment until Thursday, the 24th. And you can work on this possibly Thursday, and then we'll see what happens on Friday. I may give you an update on Friday as well and see how well my people do on this tomorrow. So thank you so much for watching this far. Check the Big Ideas Math website. The assignment is not until Thursday, so you don't have to do it today or anything, unless today is Thursday. And then email me if you have any questions or concerns. All right, guys, we'll see you.